In this video, we continue looking at the HMDA Tidyverse, and we will we've just considered in the previous video what was the effect of being self-employed in terms of being getting mortgage approved. It would at first glance seem that people who are self-employed weren't disadvantaged. Quite a few in this credit score of 1, quite a few who are self-employed managed to get were successful in obtaining the mortgage. So denied mortgage no would mean the mortgage was approved. As the numbers, as the credit score declines, that's less obvious. So individuals with a credit score of 1 or 2 didn't seem to have any issues around obtaining mortgage, and being self-employed of itself doesn't seem to be a hugely problematic factor. Okay, we had also we can take a look here at the mortgage credit score. Look at deny, and then that would give us 4 facet wraps here. So if we run using the ggplot syntax, keeping in mind we can break apart the different categories for the mortgage credit score: 1, 2, 3, and 4. 1 being the best, 4 being the worst performing credit score. The vast bulk of people were in credit score of 1 or 2. Most people don't like to mess with their mortgages, so the numbers seem to be smaller. And when we consider here were individuals, was there an effect here in terms of the denied mortgage insurance? It would appear if you were denied mortgage insurance and you were a mortgage credit score of 1, 2, or 4, in each instance there seems to be an over-representation of DMI, yes, in the those who are who didn't successfully obtain a mortgage when they made that application. So this seems to be a key factor. But the numbers, again, just visually, it would be seems fairly clear the numbers are small. We continue in a similar vein, but this time we'll use, instead of using bar charts as we've been doing geom using this ggplot syntax, geom bar, this time we'll use geom histogram, and we want to look at this kind of frequency distribution or histogram just to capture a little bit what were the actual numbers here in terms of loan to value ratio. Loan to value is quite important when you're applying for mortgages. Banks tend to take a potential view, and higher loan to value ratios tend to create for banks a higher degree of risk because there's less for a higher loan to value. The risk tends to increase for lenders given that the borrower has less skin in the game. So let's just take a look here at that distribution, and we run our code here. So for loan to value ratio, we can see that most mortgages have a loan to value ratio less than 1. The vast bulk here, or the most common value here, would seem to be between 80 and 90. A few here with a loan to value between 90 and 100, or at 100%, and then very few higher, but a few exceptions. We'd like to see of these who is rejected, who are denied, who are accepted for mortgages. So we can run exactly the same syntax again, but we introduce fill equal to deny, and when we do so, what we obtain is, again, we can break apart for the different segments here, loan to value And again, we're going with a 0.1, although we have here 0.05. But we can break apart for those who are rejected, those who are accepted for their mortgages, for different loan-to-value ratios. And I think we can say, if we're to look at the trend here, yes, as we went above 80, so 80 to 90, then 90 to 100, I think, once we touched on this segment, if we went to 100, an actual decrease in the numbers with a 90 to 100 resulted in a higher amount of rejection. So there's some evidence to suggest here, once we start pushing close to 100% loan-to-value ratio, there is a greater tendency to reject that mortgage application, right? So we have some limited evidence that as we keep increasing the loan-to-value, the amount of rejection also increases. We could perhaps change the bandwidth here a little bit and observe the effects. So if we change that to 0.5 and run this snippet of code again, we'll get more bands, if you like. Maybe not that useful. Maybe if we went with 0.2 and went in bandwidth at 0.2, we could see perhaps a better trend, and maybe we could put here 0.2 just to make that appear in the label underneath so there's no confusion. Let's run that, and okay. It's probably okay when we look at this. Okay, as the LVR, the numbers decline, so here did the decline proportionately. I think probably it's most revealing when we set this actually at 0.1. 0.1. So we go back again here at 0.1, and what we really capture here is this, that as the numbers in decrease in overall applications, the number of rejections increases. And that's because I think we're getting closer to the LVR of 1, which implies a very high level of risk on the part of the bankers, on the part of the lenders, which is something that they probably don't want to take on board. Okay, so we can do some more formal analysis of that. One simple one is to run a Logut model. Here it's not part of the Tidyverse, but we could run a model here just to see what is the relationship between the loan to value ratio and then deny yes or no. So we run and summary, and what we find is, yes, there's a positive relationship between loan to value and deny. So if an individual has a higher loan to value ratio, it is positively related to a higher amount of mortgage denial, and it's statistically significant. So we have a z-value of 7.5 and then a p-value that's very low. So statistical significance is not an issue here. And we could do this for the entire set of this swiggle, then empty full stop. That says take all the predictor variables, the 13 variables, and incorporate them into this. So we run that and get a summary output. And again, for the full, I think 13 predictors, if we look at LVR, it's fairly clear it's positive. Is it statistically significant? Well, it's 7. Sorry, it is 3. And yes, this is values less than 0.05. So it is statistically significant, and it's positive, denoting a higher LVR is associated with a higher amount of mortgage denial. So that confirms perhaps some of our initial suspicions here. Okay, we can do some more plotting relating the DIR to, so that's the debt to income ratios, that debt service to income ratio and housing expense to income ratios. And broadly, there's a positive relationship between the two. And we could introduce some color here for credit score. Okay, so we've the highest credit score to the lowest, or the best credit score to the worst credit scores. And perhaps nothing immediately that we can read here. We do a little bit more analysis, perhaps if we did it with color, and had, instead of just the credit scores, we did the approved or not approved, the DIR and HIR. Okay, it seems to be a one-for-one relationships going up here with some exceptions. Some of this might relate to a trend where the debt to income, the debt service to income ratio is generally at least as high as the household expenses to income, and could be higher. DIR as a proportion of income could be higher. If it's less than, look here at 1, if it's less than 1, less than 0.5, perhaps less than 0.4, we've more red. And once we go above 0.5, 0.4, 0.5, there's more blue, blue being associated with more mortgage denial. So higher DIR seems to denote higher level of mortgage rejection or denial. Less probably evident, a little bit perhaps, maybe we can do the same here with HIR, perhaps here at 20% on this side and 40, 50, 45% on this side. So there seems to be a cut here if we look at the code. That is going to be important later on when we look at C3s. We could filter the data so it's less than, we don't want all this. Perhaps we can just take this quadrant here, and we can do that using the filter, which means just pick out those rows that have DIR less than 1, HIR less than 1. And then the pipe operator perform the ggplot, and then the same graph as before. So let's just run that snippet of code, see what we get. And the color we've related back to the credit score. Let's do it for color coordinated for deny. And again, the trend that we might observe, more blue here perhaps than over here, and a propensity more red this side. So from this point, maybe from 35% or so, and on this side maybe below 20%, we get more red. Okay, so that may be something of interest to us. We could also do geometric smoothing of the trend just to see what we observe. We see have a positive relationship between both, but that's not too surprising. Both have income in the denominator, so nothing majorly revealed here. But the GM smooth is actually quite useful sometimes for setting out a trend, but we're not really focused here on getting a trend, so nothing really revealed. We could facet wrap and break those apart for the different credit scores, but that again, not really necessary. If we facet wrap at 1, 2, 3, 4, 5, 6, we don't really need to color code. Makes more sense if we use the syntax, but instead of using the credit score and populating with different colors here, why not use populate with different colors for either denied mortgage or approved mortgage. So let's run this, see what comes out, and that seems to make more sense. And perhaps we could improve on that a little bit by putting a trend in, and then maybe if we filtered by taking the DIR less than 1, we might see some trends here. And again, we facet wrapped for credit score 1, 2, 3, 4, 5, 6. So that's coming from our facet wrapping based on the credit score. Again, we seem to have a sea of red if we're less than perhaps 0.5 here, or 0.4 in the credit score of 1. Likewise for credit score 2, but then when we get to credit score 3, 4, 5, there's a more uniform distribution of blue and red. So if you have a high credit score of 1 or 2, the debt service to income ratio seems to be quite important. We can cut off, particularly for 1 and 2, and maybe to some extent HIR as well, below 20% or so. We can do something similar, but then that breaks down and we don't have obvious maps. So in the next video I'll continue with this.